So we can go ahead and get into some of our projects here. You can see that we had 21 entries from the community here. And so yeah, what I asked everybody to do for the submission was to basically include an executable so you can simulate the project on your machine. And I tested out pretty much all of these, I think all of them about on my machine, just to see kind of how they were doing. And also had everybody create like a write-up about kind of their performance strategies, things they learned along the way, etc. And that was super interesting. I read through all those, and yeah, there was definitely a lot of things that I had learned, and kind of it was cool to see people's kind of interesting solutions on things. So yeah, just want to take a little bit of time to kind of go through some of these submissions, highlight some cool things, and all that. So real quick,
21 entries. Holy shit.
yeah, I'm super excited. Yeah. Yeah, and people did like a lot of kind of different things. Like there were some people actually, I mean, we'll get into all this here in a sec, but yeah, I mean, I just wanted to, congratulate everybody who did end up putting a submission in. Because yeah, this is it's an interesting project, and I think everyone did a good job about getting a good working game of life in. I know there were some people who had also been working on the project that they didn't get a chance to submit. So, but yeah, still just wanted to congratulate you all for participating in this first DOTS challenge. Hope you enjoyed it. And of course, we're going to be doing some more kind of game jams and challenges in the future. Because yeah, I was super happy with this one so far. Not gonna lie, it's kind of addicting to squeeze out performance and also an awesome learning experience. Nice, that's exactly what I wanted this to be. So, okay, so real quickly, do just want to call out Brain Shack, who was the first person to submit, which I believe
No
they
image.
submitted. Yeah, no image, but yeah, I believe they submitted like right on the like Monday after the first weekend. Oh wait, and it
Oh.
switched over to the tab here, but yeah, and then they had kind of the performance strategy inside the repository here. And then also wanted to point out who is it? This one here, Pup Spectre. Was the final submission of the challenge 1 minute and 54 seconds before the deadline. So putting it
Damn.
right up towards the edge. So shout out.
Oh, he's in chat.
Hey, nice.
Right at the deadline. Awesome.
Yeah, that's awesome. So, and then yeah, also wanted to call out TJ2G. Where is that project here? Yep. So TJ2G submitted a project here, as well as this person, Alessandro Brizio. They had both mentioned in their final write-up that this was the first full ECS project that they had created. So just yeah, wanted to congratulate them on that. Coming in with little to no ECS experience and being able to create a full project, which is super cool to see. I don't remember the. I think it was on TJ's project. They said that they had gotten like a 1000 by 1000 1000 by 1000 grid at 60 frames per second, which again, your first ever ECS project, and you're able to simulate 1 million individual cells. I think that's pretty cool. So yeah, there's just a couple quick little shout outs to some random things there. And then yeah, going into kind of some of the more performance oriented things. So the kind of overall performance crown for kind of a non-ECS version, is it this one? No. That was another one that I wanted to show, but yeah, this one from Lasque 3802. This one is absolutely the highest performing one. So they did a couple different implementations. So they have a kind of one implementation that uses mostly jobs, burst, and mono behaviors. on a static sized grid. And they had like even multiple different algorithms and things to that they had tried. And by the way, I would recommend, going through a bunch of these readmes. Like this one is kind of one of the more in-depth ones where they kind of went into a bunch of the different solutions that they played around with. So there's a lot of good and interesting information in there. But yeah, so on my computer, which I think was a little bit stronger than the computer the original submitter was testing on, I was able to get a grid size of 32,768 by 32,768 running at 30 frames per second. So that is 1 billion individual cells all being rendered on my screen, simulating at 30 frames per second, which
That's
insane.
That's pretty
Insane. So yeah, that was totally blew me away. They used this LiJam algorithm, which I believe it stands for life in a register, and they linked off to it here, and they basically, from what I understand, they used kind of the similar structure to me, where it was kind of like individual, like 8x8 cells, maybe stored in like a U-long or something of that nature. Yeah. And then by using this algorithm, they're able to easily and quickly simulate the middle 36 cells, and then you only really need to account for the 28 cells on the perimeter. So you check the ones on the inside as well as the ones in the neighboring kind of 8x8 grids. So yeah, now that they linked off to this, I kind of want to go back and put that in my own project and see if I can get any performance boosts from how I have things set up here. But they also talk about doing some burst optimizations, and so rendering. So it looks like they were using like some compute shaders here for actually doing the rendering. So yeah, again, the crazy performance one was not using any ECS. It was just jobs, burst, and mono behaviors. So still, using dots, but they did do an ECS implementation of it as well. The ECS implementation, again, completely still kicks the teeth in of my implementation. Running on my computer, I was able to do a grid size of 8192 by 8192 at 40 frames per second. Which is still very, very solid. That's a lot of entities. But yeah, I would recommend, if you want to learn about some more of these algorithms and optimizations, to check this one out here. The other kind of high performing one that I noticed was from ITR. I know ITR was kind of streaming development throughout it. And then I think they put it on, the game page here. Kind of going over, some of their performance metrics and what they did. Again, they also have multiple algorithms. They talked about the different algorithms they used. I think it was cool. They tried to use like a quad tree type simulation to see if they could kind of, optimize some of the component lookups. That ended up not being as performant as doing some kind of hash mapping algorithms, which they'd shown. And again, pretty in-depth write-up about the whole development process and all. So this one, a pure ECS solution. This takes the performance crown for the pure ECS based solution. So the 8192 by 8192 grid, I was able to run that at 60 frames per second on my machine. And then doubling that to the 16,384 by 16,384, I was getting about 15 frames per second. So still, pretty solid numbers there. This also did not allocate a whole lot of memory at all. I think even on the 16384 grid, it was still at like less than a gigabyte of memory allocated on that, which was super cool. Would highly recommend, kind of reading through that one if you want to learn about some of the more kind of crazy performance optimizations to squeeze out those very high numbers. Next one that I wanted to call out was from LiJam. So LiJam wanted to call this one out because they did put up a video explaining their whole kind of solution and what they did here. I haven't watched through the whole video yet, but yeah, they kind of explain through the game of life and what they do by making a high performance Conway's game of life without using Conway's or without using compute shaders. Yeah, so this one was, pretty good one as well. So this is a 4,000 by 4,000 grid at 60
Ooh.
frames, 6,000 by 6,000 at 30 frames. And this machine is fairly comparable to mine, so I think my performance numbers were pretty similar, maybe just a little bit better than this. But yeah, I mean, still really solid numbers. Oh, this one was super cool because they had a really interesting solution to the alive versus dead cells. So most of them, like what I did and a bunch of the other ones that I saw, they use like a bit to represent it being on or off. But they actually used a full byte to represent it being on or off. So they basically had the 0 byte as it being a dead cell, and then, or no, so they had the 0 byte as an alive cell, and then 0xFF, which is basically the maximum value for a byte to represent a dead cell. Now, what they did is they basically just directly loaded this byte into the alpha
Load
channel
raw
of a
texture, yeah.
shader. Exactly. So then it basically sets the transparency on that
Well, it
for
doesn't
it
even
to
have to be a
turn it
shader,
on
by the
or
way.
off.
That very method
Well,
means it doesn't have to be a shader.
yeah.
You quite literally can
I
just use a
misspoke.
quad at
Yeah,
that point. Yeah,
yeah.
because when you use load raw texture data, there's an extra argument that you have to add, whether it's going to be in the format of RGBA 32 bits per, or if it's going to be just one singular alpha byte per per pixel.
Makes sense. But yeah,
But that's
and
awesome.
then
That's a good way to do that. Just
yeah,
have a
I thought it was a super clever solution because it's like, yeah, you have all the data and then you just put it right to this load raw texture data.
yeah, and it's already going to be a native array that you pass into load raw texture data.
Yeah. And then, so yeah, again, check out that submission from LiJam. They did make a video kind of going to that. So I definitely do want to watch that when I have a moment here. Okay. And then, so just kind of going over some of the like kind of common patterns that I saw as I was kind of like reading through these. Again, a pretty common pattern was just kind of the simple implementation that I kind of mentioned, where one entity maps to one cell, and then you store the neighbors in a dynamic buffer, just to kind of look them up that way. Another kind of common thing that I saw from a bunch of people was doing essentially like a wraparound grid. So when you're kind of like at the edge of the grid, you're looking at cells on the other side of the grid, and that way you don't have to consider the literal edge cases where you're on the edge of the grid. Yeah, funny. Or you're on the edge of the grid and you ignore those off to the side. So yeah, it's I guess it could be considered as a little bit of an optimization, because you don't have to do some extra if checks or whatever, because everyone basically always has the appropriate neighbors that they need. Yeah, a bunch of people are also doing, if you're doing the one render entity per cell, they were using the material property override to just kind of set the colors, which is basically what I was doing as well. Some interesting tricks that some people had put in is like skipping some rendering frames. So basically you would kind of like simulate the game of life multiple times per render frame. So that way you could kind of simulate the simulation faster, because you don't have to wait for rendering. You could say simulate 4 generations on the data side and then just display that once on the entity side. So I did see a couple of people doing that. One person had a kind of interesting solution where each entity mapped to a basically chunk of 100 by 100 cells, so that at that size of data, then it's basically one entity per ECS chunk. So they basically just yeah, filled up one chunk with one entity, and all the associated data on that.
Hmm.
Then let's see. Oh, and then yes, I think this was the same person. Batched the game of life to run. Yeah, this might have been somebody else, but they basically batched the game of life to run on like one section of the grid at a time. So you don't kind of have that. Again, you can't be like rendering it every single frame. But if you have like very large grids, you can kind of break it up into sections so that you're only kind of simulating one large section per I guess per like unity frame, and then once all those have been completed, then you just render that out, so you can I guess simulate it a lot quicker, I guess. A couple people did a similar solution to what I had, where I had basically the 8x8 cells stored in a U long, which they were able to use actually some. I didn't use any like crazy clever bit operations for this. This is just it was just something that I would want to kind of optimize for a little bit more if I had some time. But I guess they were able to use kind of some bit operations to very quickly calculate the next stage in that 8x8, which I guess reduced the need for a lot of if statements and for loops. And my code definitely has a whole lot of if statements and for loops and checking for specific cases. And I think that kind of leads to a lot of the inefficiencies with my current implementation. So again, it would be kind of go back to figure out some ways that I could kind of reduce a lot of that by using some just regular bit operations across all that. We've kind of already talked a little bit about rendering, but some people were saying that they were using each cell to write directly to a pixel and a texture, so that if the cell was on, they would write to that versus not. Some people use the like batch render grouping. I see one person that used the built-in render pipeline with GPU instancing and the draw mesh instance indirect. So yeah, it was kind of interesting to see how people wanted to render all these things, because that rendering, it does kind of very quickly become a bottleneck. Once you kind of optimize, do some more or less basic CPU optimizations, and you can really scale your grid up. Well, now you have to deal with the rendering. So that was something that a lot of people started doing, is kind of doing some rendering optimizations there. Couple unique submissions. So this one from Madam, I think, is that?
Yeah, I so wanted to ask about that one because I noticed it was 3D.
Yeah. So this one is 3D. I thought this one was super cool because so they actually used cubes per the entities, and so you can kind of see that how the grid kind of plays out here. And so what they were doing for alive entities is they were basically just moving the Y position up and down. I'm not sure if this is like a separate plane or if these are just like the tops of all the other cubes. Unfortunately, there's not really a lot of contrast, so it just kind of looks like the Minecraft desert, where it's just all that one single color.
Yeah, it should have some Darude in the background playing Sandstorm. Or especially with the gliders, like moving around.
Yeah. Sync it up to the music a little bit. That's a great idea. A little 3D visualizer there. But
put it on TikTok.
But yeah, so I don't know what else I wanted to say about this one, but yeah, the 1 million entities, I was able to run this on my machine without too much trouble here. And so it was cool to see kind of like a unique submission where someone was doing stuff with some 3D. Also, this one from Ani Anko, they were doing some interesting stuff as well. Let me see. I don't really know how much I can it's kind of a little bit difficult to tell with this one right here, but they also did kind of a 3D type solution where in this case the cells are cubes, and then you can use the little kind of joystick in the lower right corner to give you like a little bit of perspective to kind of get a different perspective on this one. This was also a super interesting solution because they kind of like added they kind of like gamified the game of life. So you can like try to get a high score, and basically the way that a simulation ends is once you reach a state of homeostasis where the simulation is just kind of looping over itself, is just kind of repeating. There's no additional things being added in. So again, yeah, kind of a unique solution, just kind of different than the standard game of life there. And then, yeah, as we're cutting to the end, I just kind of wanted to bring up a couple of issues that seem to be common issues across a bunch of these solutions here. One thing that I had kind of particularly seen a lot of in the Discord is that people were having some issues building the project. Like they went to build and the build failed, or if they had successfully created a build, it would crash right away. Of course, one I think common culprit for that was the whole particular entities, specifically related to like singleton entities, weren't quite loaded at the beginning of the of when the game runs, and then the system is kind of like running expecting to find that singleton entity and then just hard crashing the machine. And there were some other things. One thing that I had noticed, and maybe I'll actually end up talking to you about this after a little bit. I was having some kind of issues building with IL2CPP, and it was kind of like pointing to some like type handles with a bunch of just like random string of characters. So I wasn't able to. It's kind of difficult for me to kind of track it down.
I think I think it's related to a bug report I've seen internally.
Okay.
Maybe I'll have a chat with you after. Maybe looking at it.
Yeah. And then, but I was able to build with mono and build that. And then, yeah, someone actually kind of brings up a related question here. Does IL2CPP yield performance benefits for DOTS projects that use Burst? My understanding is yes. Do you have any additional?
Yes. Yeah. I mean,
Cool.
generally, IL2CPP should be a little faster.
Yeah.
Than mono.
Makes sense.
But that's also just mono being slow and bad.
Fair. But yeah, the mono performance ended up being like, only marginally better than my editor performance. So, most of the performance numbers that I was testing with, just in the editor was fine. But, yeah, again, did see some people having a bunch of issues with building and couldn't get the project to build, but yeah. And then debugging was also kind of another pain point for some people. I think some people were having issues getting a debugger connected and kind of stepping through some things. And, sometimes when they were like kind of making some code changes that the debugger didn't quite synchronize correctly. And this was something that I had kind of been noticing as well. Like sometimes I would kind of end up needing to restart my IDE every once in a while when things would just kind of like get out of sync, as I was just kind of like stepping through things. And yeah, I think, some people had just kind of gave up on it and just straight up did debug.log for a bunch of their debugging, which
I mean, debug.log works for a bunch of things.
It works. But yeah, I think for me, like, especially when I was doing all those like low level bit operations, doing debug.log for everything like that would have been very, very annoying. So yeah, luckily I was still able to use the debugging tools and,
I mean, in the recent update, we did fix something with breakpoints, because we kind of have to manually.
Well, there you go.
It's probably related to what Christian is talking about here.
Yeah.
So if he tries the new version, maybe he doesn't have that problem anymore. Because the thing is, when we do source generation for breakpoints to match up, with what we are we are changing the method that you have. So in your own update, if you write a system API function where you implement that function with like a copied version that has a few changes in it, and then we put that in. We also have to specify in that source generated code. When you put a breakpoint, you're putting it at code that technically doesn't run. So what line should it actually point to IL wise? Because the generated code that we've generated is it's a totally different method. And that's the code that is actually being run, the totally different method.
Yeah.
So you should still be able to put a breakpoint down in your code, in the code that you actually think is running, and it, magically gets put over to the actual point where the breakpoint actually lives, which is in the other file that we generated.
Yeah. It is kind of cool that it when it works pretty well. That it's like the code that you wrote is different than the code that's running, but you can still, kind of
Debug it.
step through the debugger through the code that you wrote.
Yeah.
And you can inspect all the values and yeah.
No, it's good and bad. It's because it is a fucking nightmare to get right, and it's also
I'm sure.
It's questionable how nice it is actually for debugging, because you're not actually stepping through the code that is actually running. But
I'll say
nice.
it was helpful enough for me to figure out the issues that I was having.
That's awesome.
So,
and that's and I mean it also is similar to what people expect. They expect to be able to put breakpoints in their code that they wrote.
Yes, yeah.
And step through it. And that's what it does.
Yeah.
It's just lucky that it sometimes gets off tracked a little. And so we have to do some bug fixes, but obviously we do them as fast as we notice them.
Yeah, no, I know you guys rely heavily on that source generation, of course, and it seems like, pretty much every time that there's a ECS update, you'll see a couple entries in there about, fix some weird edge case with source generation, and it's like, I'm sure that's, like you say, a fucking nightmare.
Sure, it's not PG. There you
go. But yeah, so I mean that is our kind of a overview of the bunch of the submissions and kind of highlights and things that I learned. Again, I would recommend, if you're interested in a lot of these optimizations, go through and read these. I think everyone did a really good job about putting in some good information during in their, along with their submissions. So yeah, Dan, do you have any kind of overall thoughts? Anything else that you wanted to bring up on the DOTS community challenge here?
No, I'm excited for the next one. This was fun. It's cool to see. And also just the fact that we got 21 submissions, that's wild.
Yeah, I'm super happy with that. So yeah, shout out to everybody who participated and joined along, hang out in the Discord and everything like that. And we'll have some more info on the next challenge or game jam soon enough. I think I kind of want to maybe get a little bit of information from the community and see what people kind of most want to do for the next one, because of course we have some ideas of things that we want to do, but just kind of see what people in the community are interested in kind of doing as well.